So how many people have joined so far? 12. So 12, it should be 13, 14. Fine.
Hello, sir. Sir, actually, your voice is not audible for me.
Okay, we will solve problems today. So let me go to the problem page. Correct. Yeah, here it is. So if you can see the problem page, assignment number 5, try question number 1. Question number 1. All of you start solving problems. Today we will practice problems. Question number 1. Question number 1, if you have any doubt, you can ask me. Otherwise, this should not take more than 5 minutes because damping is absent.
Sir,
Ah,
0.4 million kg per
no.
second,
If you have
sir.
done it, then fine, but let others find
Yes.
out. But what is this ratio, frequency ratio you are getting?
3.
Huh? That's
3.
wrong. No. What is it? It cannot be 3. At what frequency ratio transmissibility will be 10%? That you have to find out, and you have to design based on that frequency ratio.
Sir, is R is equals to root 11?
No, you should have a full confidence. You are asking me. But yes,
Sir, root
R
11.
is equal to root 11 is the correct answer. Srabha, you did a mistake in modulus formula. R should be square root of 11. That is correct. So go ahead and find out stiffness of each spring.
That is the answer 3678.01 individual stiffness.
3
678.01
मीन्स 1000 में बोलो कितना 1000 है
3678.
36,000. It appears
3600,
to
sir.
be correct. But let me wait. एक दो लोगों को और करने दो. It seems to be correct because total stiffness will be something like 1,44,000, something like that. Anyway, let others also finish it. This is easy question. I don't know why you are taking so much time.
The minus 3,663 Newton per meter.
3,600. But Sahil, you got 36,000 or 3,600?
3600.
So that is okay. Then that is okay. So each spring stiffness should be 3,600. So this shows that as an engineer, you can go to the market and you can buy the right kind of isolator spring. So if it is helical spring, you have to only specify stiffness. Damping, you cannot specify because damping cannot vary. It is standard 1% or 2%, and we don't look for damping basically. Transmissibility less than 1 means we don't look for damping at all. Okay, all of you look at question number 3. Try to understand question number 3. Try to 2 minutes, read it carefully, understand, and tell me how you will start. Question number 3. Read it carefully and tell me how you will start.
So we'll find the frequency ratio.
So can anybody suggest, but before that, statical deflection. This is there in the question. Statical deflection means the deflection under its own weight. So we are asking how much should be 100 Newton by K. So you have to find out K first. If you know K, then you can find out what will be statical deflection. Statical deflection is weight divided by isolator stiffness. So weight is 100 Newton. So 100 by K, you have to find out. So indirectly you have to find out K. So tell me how you should start.
So first we'll find the frequency ratio.
For frequency ratio, which frequency you will take? 1600 or 2200? Or a frequency in between?
Sir, we will take 2200 as the frequency.
Aditya Jadhav is saying 2200. Okay, Baki log?
Sir,
So
for
depending on the
1600,
Student in the
frequency
class.
ratio we get, we'll choose the.
Shrabha, which frequency you will take?
So depending on the frequency ratio that we are
No,
getting.
no, no, no. There is nothing depending on. You will not get your salary if this is your answer in industry.
sir, for 1600,
So
1600.
Sahil is saying 1600, Aditya is saying 2200.
1600 from Nitesh.
कौन बोला अभी 16? Nitesh is saying 1600. If I wait for 5 minutes, some new answer will come up. Just think it carefully. Which frequency should be our starting point? Is it 1600? Is it 2200? Or is it something in between?
So is it average of the
Yeah, I was expecting that somebody will come up with average. In India, we very much like average. See, the answer is very simple. You go back to the graph then.
sir, as the frequency reduces, the ratio also reduces. So our
See, answer is 1600. The reason is if at 1600, if 1600 is this point, or if 1600 is somewhere here, 2200 will be still better or not? It will be still better. But if this is 2200, my 1600 will be somewhere here and things may not be better. So if I design for 1600 as 85%, so this is 85% transmissibility. So if 85% transmissibility is achieved for 1600, for all other operating RPM, it will be better than 85%. Means better means transmissibility will be less. It will be a better situation. So I have to design for 1600. This is very important. I have to design for 1600. So, okay, question number 3 you will solve. I have given you the hint, but let me come back to the question of the last class. I had asked you that you have gone to the market. This is 25 hertz. Is the excitation frequency is 25 hertz. And
Yes, sir.
how would you select an isolator stiffness? And how much you will select? This question was asked on Sunday.
Yes, sir.
Bolo, answer bolo.
Sir, K will be 12 giganewton per meter and R will comes out to be 1.433.
Why not 1.5?
Yes, sir. But K will decrease and we should not decrease K because it will spring will compress more. We shouldn't want that.
But if the spring can compress, let it be compressed. What is wrong?
Sir, it will reach
Springs are, no. Let me
solid
tell
land.
you. Springs are supposed to be compressed. I mean, that is why springs, we buy market, spring in the market. You buy a spring and then if you cannot say, no, it should not compress.
want compression, but at minimum, because if compression will be more, then it will reach the solid length.
Suppose it doesn't reach the solid length, then
Sir, but its absorption will be less.
no. Suppose the spring has sufficient range for compression. Solid length is not a problem. Then
Then
will you go for 1.4 or 2.0?
2.0, sir.
Why not 10, 10.0? Why you will stop at 2.0? Why not 10.0? If solid length does not become a problem. I agree. Solid length, at some point of time, solid length will definitely become a problem. But as long as solid length is allowing us, can we simply increase the frequency ratio? Or in other words, in practical application, the graph tells us that increasing the frequency ratio, we get better situation, means lower transmissibility. The graph tells us. Even if the graph tells us, practically, we cannot go for a high value of frequency ratio. Why? That is my question. Why? Even if solid length definitely is one factor. I accept it. But suppose solid length allows us up to 10. Does it mean that we can go up to 10 or some other problem we have to consider?
Amplitude will increase more.
That is the thing, amplitude of the machine. And amplitude of the machine is F0 by K multiplied by DAF. F0 by K into DAF. So if K decreases, DAF also decreases. Now this is very interesting. As frequency ratio increases, dynamic amplification factor decreases, but F0 by K increases and the product increases. So machine vibration increases. Transmissibility is improving, but machine vibration increases. So we have to stop somewhere. Now there is no mathematical value where we should stop. It depends on the machine supplier guideline. Every machine supplier, they specify the maximum vibration amplitude. Every machine, if it is turbine, if it is pump, they specify a particular vibration amplitude. We cannot cross it. We have to stop. So whatever transmissibility we get, we have to stop at that particular frequency ratio. So this is little bit of restriction, but as an engineer, we should always go for R greater than 1.4, that is root 2. But how much greater than root 2? That is decided by allowable machine vibration. Okay, so more or less you got some idea about force transmissibility. Now let me go to support transmissibility, okay, or motion transmissibility. So this is an example. There are many other examples, but this is an example which represents motion transmissibility. Now motion transmissibility means we have a system where disturbance comes in the form, not in the form of force. Disturbance comes in the form of displacement. varying displacement. So if a vehicle is moving on an uneven road, then the wheel goes up and down. So here the disturbance is coming in the form of a varying displacement. Now this varying displacement at the bottom is transmitted to the body of the vehicle. So this body of the vehicle will also go up and down. So output motion is x2, input disturbance motion is x1. Here x1 is cause, x2 is result. How much? X2 will depend on x1. That is represented by a term called motion transmissibility. In force transmissibility, we compare transmitted force with respect to actual force. In motion transmissibility, we compare transmitted motion with disturbance motion. So if amplitude of transmitted motion is capital X2 and amplitude of disturbance motion is capital X1, then ratio of capital X2 by capital X1 is motion transmissibility. So motion transmissibility happens in vehicle. Motion transmissibility also happens for buildings under earthquake. So that we will discuss, but first let us discuss a vehicle. For simplicity, the vehicle has been modeled by one wheel. Actually, a vehicle can have two wheels like a motorbike. It can have four wheels like an automobile. But we are making a very simple model which may not be correct. But right now, we are modeling the vehicle by a single wheel. In between the wheel and the body of the vehicle, we have a suspension so that the stiffness is K and damping is C. If this wheel is given an up and down motion x1t, then how much will be motion x2? That is our objective now. So what will be equation of motion? लिखो. इस केस में इक्वेशन ऑफ मोशन क्या होगा? फ्री बॉडी डायग्राम, दैट्स ऑल. Free body diagram, you can do it. What will be equation of motion? Equation of motion will be very simple. mx2 double dot plus c into x2 dot minus x1 dot plus k into x2 minus x1 will be 0 because no force is acting here. So equation of motion is this. This is the equation of motion. So here the mass is going up and down by an amount x, and the base. So this, for the vehicle it is a wheel, but for some other application we will call it a base. So base is moving up and down by y. Then the equation of motion is mx double dot plus cx dot minus y dot plus kx minus y is equal to 0. Or in other words, mx double dot plus cx dot plus kx is equal to cy dot plus ky. इसको लिखो, ए डेरिवेशन अपना नोटबुक में लिखो, पिक्चर ड्रॉ करो और ए डेरिवेशन अपना नोटबुक में लिखो, so that you right now you understand how the answers are coming. So here also we will apply that technique of using complex quantity. Our force, sorry, yt is a sinusoidal variation. It may not be. The unevenness in the road may not be a sine curve. But right now, let us assume that unevenness is a sine curve. Then which can be represented as y sine omega t. Now this omega depends on velocity and wavelength. So if I go up, now from wavelength is peak to peak. So if this is wavelength, then frequency omega will be 2 pi into velocity by lambda. Lambda is wavelength on the road. Velocity is moving velocity of the vehicle. So 2 pi velocity by lambda is omega, and that omega comes here. This is a real quantity, but again we apply the complex mathematics. So we take it as a complex number. We assume the solution x also to be a complex quantity, and if we put this and this a complex quantity in our equation of motion, we get this. You have to write down everything. I will give the PPT, that is another thing, but you write down and then you see if any mistake, anything is wrong. So finally, if we take the ratio of the magnitude, we get so transmissibility will be the transmitted amplitude x divided by disturbance amplitude y. So that comes out to be same formula. So motion transmissibility also finally comes to be or found to be same as force transmissibility. So the derivation you finish first. I'll go back again. This derivation you finish. So if you agree with the formula, and this is the motion transmissibility, but you have to be very, very careful. Although the formula is different, there is a very important difference when you have to calculate motion transmissibility compared to when you have to calculate force transmissibility. What is that important difference? I mean, if a vehicle is moving on a road, we can find our objective is finally how the vehicle is vibrating. And that is represented by amplitude of transmitted motion x bar, or x, capital X. That is represented by amplitude of transmitted motion, capital X. As an engineer, we have to keep it small as possible. Now, how much capital X will be can be calculated from transmissibility and road waviness amplitude. Formula is same as force transmissibility formula. But there is a very interesting difference between force transmissibility and motion transmissibility. What is that? Not
Here it
mathematical.
is having opposite. From base to the system it is going.
नहीं, तो I'm saying transmiss. See, this is a sine curve. So sometimes it will be positive, sometimes it will be negative. It is a sine curve. So positive part and negative part both will coexist. Okay, let's solve a problem and then I'll keep the question open. There is a very interesting difference which makes motion transmissibility more difficult for engineers. But let me go to the problem. A sample problem, कौन सा लिया जाए? I think.
Sir,
अरे हाँ बोलो.
sir, when damping is absent, then it might be
No, that is
possible.
not the important difference. Okay, I'll come to that. Question number 4. Solve करो. अभी solve करो.
Sir, which question? Fourth number.
Question 4. Motion transmissibility, question 4. Critical speed is the speed for which omega will match natural frequency. Natural frequency is square root of k by m. ऊपर नीचे g से मल्टीप्लाई करो, k इंटू ग्रेविटेशनल कांस्टेंट g, नीचे में mg. So mg by k is static deflection. You have to use that small formula. Static deflection is weight divided by k. So mg by k is given. And from that you have to find out natural frequency. See, omega is coming from this formula. I have already, yes, 2 pi into velocity divided by lambda. When this omega matches with natural frequency, the velocity is said to be critical velocity for the vehicle. Okay, so in this problem, you have to first find out omega n. and then you have to find out what velocity will make omega is equal to omega A. That is the critical speed. कितना आ रहा क्रिटिकल स्पीड?
82.36.
अरे यूनिट क्या है?
Kilometer per hour.
Hour. So 52.
82, sir. 82.36.
हाँ, तो फिर if the vehicle is moving at 65 kilometer per hour, then the transmitted vibration amplitude, रोड वेवीनेस एम्पलीट्यूड से ज्यादा होगा कि कम होगा? So you have to find out value of R. First you have to find out omega when the vehicle is moving at 65 kilometer per hour. Omega in you already know. In R निकालो. Damping यहाँ पे 0 पकड़ो. Damping is not mentioned. I mean damping is negligible here. So transmissibility is 1 upon modulus 1 minus R square. But we have to find out frequency ratio R.
Sir,
हाँ,
sir, if you are getting two possible frequencies, frequency ratios, then which one do we have to consider?
no, why you should have two possible frequency ratio?
So since
Natural frequency is 1. How can you get two natural frequencies? See,
frequency
one
ratio.
is negative frequency ratio you can never take. Two possible means one is positive, one is negative. Negative you can never take. There cannot be two different positive values for frequency ratio. You cannot have.
Yes, sir.
So how much will be vibration amplitude at 65 kilometer per hour speed?
Sir, 20.18 centimeter.
So are you getting more than road waviness amplitude or कितना मिल रहा बोलो?
20.18. More than
हाँ?
20.18.
20
Yes, sir.
centimeter.
Yes, sir.
Let me wait for one more answer. Damping is 0, so transmissibility is 1 upon modulus 1 minus r square. अरे बाकी लोग क्यों इतना टाइम ले रहा? ओके ठीक है क्लास आई हैव टू एनीवे स्टॉप द क्लास तो up to this complete problem we have solved question number 3, question number 4, question number 1. Remaining problem you will solve. I am sending this PPT right from the beginning, that is vibration isolation last class, and in today's class PPT along with this problem page. Within 5 minutes I am sending it. Srabha, you will circulate with others. ठीक है? तो आज का क्लास हो गया. चलो, you can leave now.
One more PPT is also there, sir, from second last class.
टॉपिक बोलो.
Half power bandwidth.
वो तो मैंने क्लास में डिराइव करने को बोला. I said that you all write down and derive it.
Yes, sir, but
The derivation I asked you to do it in the class. हाँ, उसको भी PPT चाहिए. That derivation was done in the class. So every time I will not give PPT. ठीक है? This PPT vibration isolation PPT complete PPT I will give. You will get it within half an hour.